everyone, and welcome to this video about how one of the most important ideas of mathematics, the functions, has changed and evolved over time. Today, we'll travel through different centuries, meeting six important thinkers: Nicolás de Orense, Galileo Galilei, René Descartes, Gottfried Leibniz, Leonhard Euler, and Peter Dirichlet. Each of them saw the world different, and their ideas help shape the way we use and understand the functions today. You might think of function as something from school, questions like if x is 2x plus 3, but behind those symbols there's a long story full of curiosity, creativity, and progress. Number 1. Nicolás de Orense, Geometry and Proportion of the Middle Ages. We begin in the Middle Ages with Nicolás de Orense, a Spanish thinker from the 3rd century. Mathematics in this time was not as formal as it is today. Not like 1 plus 1 was the same. Not complicated. Nicolás de Orense worked with proportions and relations between lengths and geometry. He was interested in how quantities related to one another, especially in the context of architecture. His work shows us that even in times when tools were limited, humans were already trying to describe the world with rules and patterns. 2. Galileo Galilei, Time, Motions, and Language of Nature. In the 7th century, Galileo Galilei changed science forever and ever. He studied falling objects, pendulums, and projectiles. One of his discoveries was that the distance of object falls in proportional to the square of time it has been falling. In math, that's d equal to 1/2 gt to the power of the cube. Square. This is a perfect example of the function in real life. The input is time, and the output is distance. Galileo believed that nature was written in the language of mathematics, and with this, he helped us understand the universe now just by observing. 3. René Descartes. René Descartes wrote something revolutionary, the Cartesian coordinate system. You know, the x and y axis. X, y. For him, geometry was mostly about drawing shapes and measuring, but Descartes had the idea of describing shapes with numbers and equations. For example, a simple parabola like y equal to x to the power of square, like this. If it's negative, is down. Now we draw and study it in a plane. Suddenly, curves became equations, and equations become curves. The 4th one, Gottfried Leibniz, defining the function. Leibniz, a German mathematician and philosopher, gave us many concepts used in calculus, including the word function. Like, we need to understand what we are doing and the name, how to name it. Some function was something that described how a variable changes in relation to another. He looked at curves and asked, how steep is this at any point? What is the area under this curve? His work was a major step in moving from thinking about functions, just static formulas, to seeing them as dynamic processes, change over time and space. Calculus, invented by both Leibniz and Newton independently, is full of functions that describe moments, change, and relationships in nature. Number 5. Leonhard Euler, a function for every role. In the 17th century, Leonhard Euler gave the word function in modern meaning. He introduced the notation fx, where x is the input and fx is the output. Like f, we put the f, the parentheses and the x equal to the function x to the square plus 2, for example. Notice that a function is any rule that takes one number and gives back another. This could be a simple rule like f parentheses x equals to 2x or something much more complex. Thanks to Euler, we now had a way to write and understand functions clearly. He made it easier to others to study them, graph them, and use them in all areas of math, physics, engineering, and even comics. His influence is everywhere today. If you've ever seen fx in the math class, that's Euler's legacy. Number 6. Peter Dirichlet, accepting all kinds of functions. In the 19th century, Peter Dirichlet took things further. He asked, what exactly is a function? Until then, people thought it had to be continuous and nice-looking curves. But Dirichlet said, no. Even strange, jumpy, or predictable rules can be functions as long as they assign one output to every input. It was a big idea. It allowed mathematics to assign more complicated and abstract kinds of functions, including those that don't follow usual patterns. Thanks to Dirichlet, we now accept all types of functions in modern mathematics, even ones that are possible to draw. So, from the proposition of Nicolás de Orense to Galileo's falling objects to Descartes' graphs, to Leibniz's calculus, Euler's clear notation, and Dirichet's wide definition, the idea of function has grown and evolved over hundreds of years. Today, functions are everywhere, in physics, computing, and finances, in biology, and courses in school. What began as a way to describe single relationships, now one of the most powerful tools in all the science and maths. Now, thank you for joining me in this journey through the history of functions. I hope it helped you see just how deep the fascinating this concept really is, and demonstrate some interesting class matters. Don't disrespect the math teacher. Bye. If I don't see you, good afternoon, good evening, and good night.